Okay, so on an isosceles triangle, there are at least two congruent sides. Those two congruent sides are called the legs. They are the same length. Then you have the vertex angle up here. The base is this side, the third side that's not, you have two congruent sides and then a third side called the base. And then the base angles are right here. They are opposite the congruent sides and the base angles are congruent. Okay, and that segues into the first theorem. For today, base angles theorem. This is also sometimes called the isosceles triangle angle theorem, or there's different variations of this. But essentially it means what I just said. When you have two congruent sides on a triangle, the angles opposite those congruent sides, so the two base angles, are congruent. They're the same measure. And then we have the converse of that. If you're told that you have two angles that are congruent in a triangle, then the sides opposite those congruent angles are congruent, and you have an isosceles triangle. Okay, so for the first set of examples, it says name the congruent parts of each triangle. So here it shows the two congruent sides here. So FD, segment FD is congruent to ED. And then opposite those congruent sides are the base angles, and they are congruent as well. So angle F is congruent to angle E. And for B, we have the two base angles that are congruent here. Shows a little arc there. And then opposite those congruent angles are the congruent sides. So angle T is congruent to angle W. And then segment TO is congruent to WO. Up here, there is a more complex diagram. Use a diagram to answer all the questions. So you just have to look at this in pieces, whatever it's asking for. So it says segment AE is congruent to DE. So find segment AE right here and DE, and it wants to know what angles are congruent. So it's talking about like the larger exterior triangle. Opposite this congruent side would be this angle, and then opposite this congruent side would be this angle. So angle A is congruent to angle D. Then it says that AE, segment AE right here, oh, sorry, AB right here is congruent to EB. So for this triangle, this angle would be congruent to this one. So angle A is congruent to this angle. I wouldn't call this angle E though, because E can refer to a lot of different angles here. So I need to be more specific. AEB would just refer to this part. Then it says if angle D right here is congruent to CED. So when I identify the angle CED, so it's talking about this angle right here, if they are congruent, which sides are congruent? Well, this side right here would be congruent to this. So EC is congruent to CD. And then if EBC, this angle here, is congruent to ECB, this angle here, then this side right here would be congruent to this side. So EB would be congruent to EC. Okay, so now that we are familiar with the congruent parts, they're going to bring in numbers, and then we just have to identify which parts are equal and then figure it out from there. So it says find the unknown measure in the triangle. So here for A shows that these two sides are congruent, so therefore the angles opposite those congruent sides would be equal. So these two base angles are equal. So if this is 50 degrees, then this is 50 degrees. And then this angle up here, the three angles of a triangle add to 180. So we can do 180 minus 50, and we're left with 80 degrees. And for B here, it shows that these two angles are congruent. So then the sides opposite those angles will be congruent. And if this is 5 centimeters, then this will be 5 centimeters. And for C, these two sides are congruent, so these two base angles will be equal. If this is 46 degrees, then this is 46. And then to find the third one, just 180 minus 46, and it comes out to 88 degrees. Okay, then D, congruent sides, so that means that these two base angles are congruent. For this one, what we have to do is 180 minus 40, so we get 140 degrees. And then these two are the same measure, so this degree measure needs to be split evenly among those two angles. 140 divided by 2 is 70 degrees. And E, here it shows these two congruent, and then the angles opposite that would be equal, so this angle is equal to this. So if this is 63 degrees, so is this. This marker is dying. And then this angle here, 180 minus 63, and the leftover is 54 degrees, so that's this vertex angle here. And of course, they'll bring in a little bit of algebra sometimes. It shows that these two base angles are congruent, so therefore these legs are congruent, the ones opposite the base angles. So we'll set these equal to solve for x. So 3x plus 4 equals 22. Divide by 3, x equals 6. Okay, and then flip the page. Okay, then on this side, stays pretty simple. Now we're talking about equilateral triangles. So equilateral triangles are triangles that have all the sides equal. So all congruent sides. Okay, so in an equilateral triangle, all the sides are equal, and therefore all the angles opposite the congruent sides are congruent as well. So all the angles are equal. And then in a triangle, all the angles add to 180. So to find each angle, 180 divided by 3 is 60 degrees. So that makes them all 60 degrees. So when you have an equilateral triangle, all the angles are 60 degrees. Okay, for the first example, it says find the measure of all the angles, shows all the sides congruent, so therefore all the angles are congruent. So 180 divided by 3 is 60 degrees, so therefore all your angles are 60 degrees. Here it says find the length of ST, shows all the angles are congruent, so therefore we have an equilateral triangle, meaning all the sides are equal. So if this is 5, then this is 5, ST equals 5. And it says find the value of x and y here. It shows all the sides are equal, therefore all the angles are equal. And then in an equilateral triangle, all the angles are 60 degrees. And so we can set each of these expressions equal to 60. So y minus 10 equals 60, and x plus 5 equals 60, and we can solve for x. plus 10, y equals 70, x equals 55. Okay, then on the other side, example number 4, word problems. It says the measure of each congruent angle of an isosceles triangle is 6 less than the measure of the vertex angle. So I'm going to draw an isosceles triangle here. These two base angles will be equal. The measure of the congruent angles of the isosceles triangle is 6 less than the measure of the vertex angle. So if the vertex angle is x degrees, then this is 6 less than that. And then to solve for x, these three angles add up to 180. So we can do x plus x minus 6 plus x minus 6 equals 180. 3x minus 12 equals 180. Plus 12 plus 12. 3x equals 192. Divided by 3. 192 divided by 3 is 64. So if x equals 64, this is 64 degrees. Here, 64 minus 6 is 58 degrees. 64 minus 6, 58 degrees. Okay, and then for this one's similar. It says the measure of the vertex angle of an isosceles triangle is 15 more than the measure of each base angle. Okay, so I'm going to draw my isosceles triangle here. These are the same. We got our base angles. The measure of the vertex is 15 more. So x plus 15, and then this is x and x. Okay, then all three of these added up equals 180. X plus 15 plus x equals 180. Combine your like terms. See, 5 degrees. So this is 55 degrees, this is 55. And then this would be 55 plus 15, which is 70 degrees. That's as well. So you still have 20 minutes left in class. Work on your homework 5-5, and then if you finish that, start your weekly ALEKS. You know, as you have questions, you may begin.